All right, we're back from our break, logicians, and ready to learn the second set of replacement rules, which you will find in your textbook in Chapter 8, Section F, transposition, material implication, material equivalence, and exportation, and tautology. Let's get started. First of all, is transposition. What's in the box is what you want to memorize. Now, this allows you to work with a conditional statement. It says, if P, then Q is logically equivalent to saying, if not Q, then not P. So you can move in either direction across that. So, this is almost like it follows from modus tollens, right? Yeah, if P, then Q, not Q, therefore not P. This is like a condensed version of that, right? It's expressing the same idea. So great, it's very useful. Here's what not to do. If you have if not P, then not Q, that is not equivalent to if P, then Q. Wrong. You know what that would be equivalent to if you applied transposition to it? It would be if not Q, then not P. That's what it would be. So, and then you use double negation. Second, material implication. Another thing that you can do with conditional statements, and this is super powerful and useful, okay? It lets you turn a conditional statement into a disjunction, or a disjunction into a conditional statement, and there are times you're going to need to do that. If P, then Q is logically equivalent to saying either not P or else Q. So if it's raining, then the streets are wet. That's logically equivalent to saying either it's not raining or those streets are wet, right? Okay, so here's a way that you could apply it. You've got either if B then C or D. And if you apply material implication to that, you can apply it just to the conditional statement that's inside the parentheses, because you can apply replacement rules simply to part of a line. Isn't that cool? So if you do that, you get either not B or C or D. And then think what you could do with that. I mean, you could apply then the associative rule, and you get, or there's lots of cool things you could do that. So it's useful. Here's how to screw it up. If S, then R, not S and R. What? No, that should be a wedge, not a dot. So don't do that. And then, or if you got this one, either not D or G. And then line 2, they go to it's not the case that parentheses, if D, then G. No. That should be if D, then G. That's what line 2 should be. If D, then G. There's no, drop that not totally out of it. Third, material equivalence. Okay, this one tells you what to do with triple bar. Remember, the triple bar means if and only if. It's like horseshoes pointing in both directions. So if I say P, if and only if Q, that is logically equivalent to saying if P is true, then Q is true. And if Q is true, then P is true. That's if and only if. Also, P, if and only if Q is logically equivalent to saying either they're both true or they're both false. Either P and Q are both true, or P is false and Q is false. And those are ideas which, that's the idea. If you remember your truth tables with triple bar, that should be very familiar to you. Okay, so a valid application of it, you got Q and R, or not Q and not R. Well, if you got that, you got one side of material equivalence. You can just say conclude immediately to Q if and only if R. Boom. Because remember, you can go in both directions across the double colons. Logical equivalence means you can just swap them in and out no matter which side of the double colons are there. Misapplications, you got G if and only if H, and they said G and H and not G and not H. What did they screw up? That's right, the main operator here, the dot that's outside the parentheses, should be a wedge. I mean, they can't be a dot because that'd be crazy. It's saying they're both true and they're both false. That's a contradiction. Or over here it says, if M then Q, or if Q then M, and then they try to include M triple bar Q, or they screw up. Well, line 1 needs to be a dot, not a wedge. The main operator. That's the problem. Exportation. Yeah, I don't have a clever mnemonic, but you're clearly exporting something outside parentheses, sort of, maybe, I'm not sure. Anyways, you got if P and Q, then R. That's logically equivalent to, well, if P, then if Q, then R. Yeah, that's what it is. So memorize that. And finally, tautology. This is easy. P is logically equivalent to saying P or P. It's also logically equivalent to saying P and P. Duh, right? Duh. Okay, so great. Bear that in mind, it'll be useful to you someday. Okay, here's again, they give you like a bunch of tactics, and you can, I guess you can memorize all these if it helps you. I mean, it's all true, useful. I've never thought about them. Like I said, I've got a method which will get you to the same ideas, I think. Use this if it helps. What about if we apply the material implication rule to this? If and, then not M, and not Q. Now, do you remember the material implication rule? That's the one that says if P, then Q is logically equivalent to either not P or Q. So it applies to a conditional statement or to a disjunction. Now we've got a conditional statement inside the parentheses. So if we're going to apply material implication, we're going to apply it to part of a line, namely to this part of a line that's inside the parentheses. And that what we're going to need to do is negate the antecedent and turn that horseshoe into a wedge. So here's what we should get inside the parentheses. Either not N or not M, and not Q. All right, again, let's think kind of in the wrong direction from premises to conclusion about this proof. So, and basically it invites you to think, you know, from the premises forward. I'm trying to get to T and R. Obvious to me. I could try to break the T off and then just get R by itself and, you know, add them together with conjunction to get T and R. I don't really know how I could get the T, get the R by itself, that to use then conjunction. So let's see what we can do with these premises. Okay, what can you do with premise 1? What rule could you apply? Oh, that's right, distribution. And you know, there's another rule I could apply to premise 2. You know what it is? One of my favorites, probably my favorite replacement rule, De Morgan. But I'm not sure which of those is going to do me any good. Let's start with distribution. So if we apply distribution to line 1, you get what? That's right, T and S or T and R. Ooh, we're close. So now T and R is one of the disjuncts in a disjunction. What implication rule do you know that will give you one of the disjuncts out of a disjunction? Yes, disjunctive syllogism. Great job bringing that back from 2 weeks ago. So, now, what premise do we need in order to apply disjunctive syllogism to line 3? We need the negation of the other disjunct. We need not TS. Do we have not TS? Heck yes, we do. Up there in line 2. So voila, disjunctive syllogism, and we're at T and R. Elegant and beautiful. Okay, so memorize these rules, get them cold, and watch my other video about the method of how to use these replacement rules.